Spacca tutto.
Hello, everyone, and welcome back to Machine Learning at Lunch with me and Giacomo. And today, Giacomo is going to talk about this interesting paper about berries. And this is something that is related to our European project called Ferox. So, Giacomo, please tell us more about it.
Yeah, thanks for the introduction. And this one is a paper that I read very recently, and I thought it was quite interesting, as you were saying, is mostly because it relates to what we are doing or actually trying to do with the Ferox project. And so I thought I would give it, a go and see what they propose. So this paper is related to both at the technique for segmenting and then counting cranberries. And on the other hand, it also provides a data set and was developed by Akiva and other researchers from Rutgers University in the US. Um, so let's start from a general introduction about the problem of detecting berries. So as you know, there are many different types of berries, but the thing that they have in common is that essentially they are very small fruits that are actually somewhat hidden in bushes or whatever, and also they are essentially round objects, if you like. Okay, so not necessarily a sphere, but quite close to it. Um, and so when we want to essentially use artificial intelligence for detecting these berries and then counting them and then make probably some uh, prediction or support, I don't know, the decision of a berry picker or anything like that, uh, we need to be able to assess their position and their number as usual, and this is difficult exactly because of the fact that they are small and they are possibly hidden um, inside the vegetation. And in this sense, sometimes people use um, some model to estimate the yield for the say for the current year based on data from previous years. Um, but this thing is actually quite so it comes with a problem essentially because um, there's a problem with the ecosystem, meaning that there can be variations in the weather, or I don't know how much rain has poured in the last month, something like that. So if you just base your prediction on historical data, you might incur in some errors. And so what these guys
So,
are actually trying to,
again,
yeah,
there's climate
yeah,
change. This is an issue that we're trying to
yeah,
tackle as
exactly.
well. So,
Yeah, exactly, exactly. So the problem is exactly climate change, if you like. So, I mean, that's the bottom line here. So it could be that because of climate change, things are changing very fast, even over the course of a year or two or something like that. And so what like the model that you used 3 years ago might not apply to this year crop or whatever. So it's very hard in general to use this historical data. And so what these guys are actually trying to do is, well, they are saying, okay, let's say that we don't use any historical data, but instead, let's try and do this. So let's try and, I don't know, predict the yield for this year using a non-invasive method based on drones in this case. So what they're trying to do is first they want to create a data set. So the idea is, okay, I can actually fly a drone with some decent camera on it and take lots of images of these berry bushes, and then I will analyze these pictures. And so this is the first part of their proposal. So the creation of a data set, in this case, focusing on cranberries, but of course could be more general. Um, Okay, and then once we have done this, what they want to do is they want to segment and count the berries, and this is precisely to overcome the problem that I was describing before. Um, I don't know if you have any question up to this point.
no, I'm curious about
Okay,
this.
so the data set they are so let's just take a look at the images. So this is a typical image that they are taking with the drone. So you see that there are these cranberries that are these little red blobs here, and then there are lots of leaves that might occlude the cranberry. And here you see that there are some red spots here and blue spots. Of course, these one are not natural, but they are actually introduced by the researchers themselves. And the reason for introducing this is to make the segmentation easier in the following sense. So what they do is that they want to create this data set with 21,000 images, RGB images taken with the drones, and they are actually quite careful in taking these pictures at different times in the day. And the reason is that they want to, have different lighting conditions. So maybe at dusk or at dawn, midday, afternoon, and so on and so forth. And when they create this data set, they also annotate this data set in two different ways. So the first one is that they annotate with single points the center of the berries and some background points. And this relates to this picture here. So you see that the blue dots are always like in the center of the berry, and the red dots are actually just background, so mostly leaves in this case. And so each image is annotated in this way. And plus, they also annotate it like with the standard segmentation. So they will create some pixel-wise annotation like this, isolating the single berry as it appears on screen. So this is and this is when I'm saying that they annotate the entire shape of the berry with a mask essentially. And what then? Then they are trying to segment these images with what they call a triple S network. And this triple S is because they are considering a segmentation plus a split and plus a shape type of loss function. And this loss function is built upon a U-Net. So U-Net is a neural network that was developed, I think, in 2015 by a researcher that they were interested in mostly in medical imaging, so segmenting things inside the human body, more or less. And what they developed this very cool U-Net, which is then has been extensively used in all sorts of segmentation tasks. But in this case, what they want to do is actually they want to use some particular loss function, which is divided in three contributions. So the first one is what they call the segmentation loss, quote unquote. So this means that they will use this positive and negative points here to create a sort of first approximation of the final segmentation, and this will contribute to this segmentation loss function. So they want essentially to localize in a sort of rough way the blob, meaning the mask of of the cranberry using these points. Uh, then they are actually using a second loss function, which they call split. And essentially, the idea is that they want to discourage overlapping. So they are actually trying to avoid that, um, different blobs overlap with one another. And finally, and I think that this is the most relevant. So I think that the most interesting part are this thing with the positive and negative points. And the last thing that I find interesting is this shape loss function. So what they're doing here is that they are saying, look, we know that like a cranberry will have a sort of spherical form in a way, or if you are into D, like be a circle or something like that, or quite close to a circle. And so when they are producing like a mask of the putative cranberry, they essentially want to uh, favor those masks that are actually spherical, right?
Mhm.
Because we have a prior on the form of the final result. And so they actually use this information to guide the detection. And so this is the last step. And so all in all, they are they are capable essentially of providing all of this code. So they provide either, both the dataset and the code for this, which is implemented in PyTorch. I haven't tried it yet, so I was playing around with it, but still haven't made any serious contribution or actually didn't do much with it. But still, I think it's pretty interesting for a number of reasons. And I also think that it will apply to our use case because I mean, cranberries are of interest to us, but not just cranberries. So as you know, we actually using more type of berries. So in Finland there are lots of, I don't know, maybe 10 different types.
Mhm.
So, but the idea here is very much the same.
Yes.
Um, and also they provide the data set. So I downloaded the data set, which is not complete for some reason. I don't know. So I'm texting the authors to try and release the missing part because there should be 21K images, but I also, I mean, I just found, I don't know, 200 of them or something like this. So there is definitely something missing. I'm not sure why this is the case. So I'm trying to, you know, get back the remaining part.
Okay.
Yeah, and that's pretty much what I wanted to say. I don't know if you have any question in this. I've been quite
Uh,
general, probably, like a bird's eye
not
view of
really,
the.
not many questions. It was all clear. I guess we could try to use this network for our purposes. Maybe first we would have to add another step in order to maybe classify the different types of berries, but then we could have this unit to segment them and count them and do whatever we need to do with this information.
Yeah,
Uh,
exactly. So yeah, in our case, we should be able to suggest to the berry pickers the right spot, right being the one with more, uh,
berries.
yeah, with more fruit, of course.
Mhm.
Um, yeah, and I think that
Definitely.
the only thing that is missing from our perspective, probably, and this I'm discussing with the other guys from the consortium, is that we will also need to make sure that we keep track also of the position, like GPS position or something like that. So we want to know that the image with, I don't know, 100 berries is in the position XYZ or something like this, because that will help, of course, the discovery and the tracking of the most appropriate places. So that's another
But I
thing.
guess this is not a problem with modern drones because I guess
No,
they
exactly. Yeah. I think we should mount some sort of GPS, but I don't think that should be a big deal. So it should be pretty straightforward, I think. Um, so yeah, I'm pretty positive about that.
okay, and I guess that's all for today. See
Yeah,
you in the next one. Thank you.